तो free radical substitution के अंदर what we had talked about was कि you had initiation, Cl radicals were produced, which were very, very reactive. And those Cl radicals will go on and they will start attacking hydrogen atoms. They will bind the hydrogen atoms with themselves, form HCl. तो फिर वो दूसरा radical बन जाता है, propyl radical, and the propyl radical will attack the Cl and join one of the Cls. Another Cl radical gets produced, which goes and attacks some other hydrogen atom. The same thing just keeps on repeating endlessly. और फिर last step था वो termination, which was that any of the free radicals could just combine together and you will form the final product. ठीक है, तो और इसमें remember this that ये तो mechanism है, but remember this, the important thing is that free radical substitution, the chlorine or the halogen could be attached to any carbon chain, except that it's going to be very, very randomly attached. There's not going to be any specific position. It could get attached to any of the hydrogen atoms. Okay. So moving on. That's alkanes. Okay. So moving on. So next. As a next is 1 second. So let's talk about. So let's talk about alkenes now. Alkanes mein bas, I mean, that was pretty much the only. So that was pretty much the only reaction for alkanes. Combustion, I'm not going to talk about combustion. You already know about combustion, so we're not going to go into that detail. अच्छा एक थोड़ा सा पढ़ लेते हैं. We can talk about quickly talk about cracking of long chain. बल्कि we'll study that in cracking कर लेते हैं, cracking of long chain hydrocarbons. So
सर आपने अभी स्टार्ट किया?
हाँ, बल्कि इसमें ना वो क्रूड ऑयल वगैरह सारा ही ठीक है. Just very briefly, very quickly, I just probably, I mean, that's where you extract all the hydrocarbons. So most hydrocarbons that are around you, they are plastics, etc., medicine. All of them are actually, and especially energy, you get it from crude oil. So crude oil ki jo fractional distillation hai na, that's I'll just copy paste an image. You've already done that in O levels as well. Fractional distillation. तो उसका एक इमेज उठा के नहीं जोड़ देते हैं. आई गेस थोड़ा सा ज्यादा डिटेल्ड हो ये ठीक है. अच्छा नॉट श्योर ओके. अच्छा this one. So pretty much self-explanatory. Okay, no need to discuss this, except for the fact that you get small molecules at the top. Okay, they've got low boiling points, and you've got large molecules at the bottom, and it's a mixture of hydrocarbons. So you're going to get a lot of stuff. Bitumen, okay, that's your raw crude stuff that's left at the bottom. That's got very high. You make roads out of it. Fuel oil, lubricating oil. Okay, that's polishes, waxes, etc. Diesel, kerosene, naphtha, petrol, and finally gasoline. Okay, so that's most of your stuff over here. इसी में ना there's a thing called cracking of long chain hydrocarbons because long chains are not very useful. So we'll quickly discuss कर लेते हैं उसकी conditions like that, and then we'll move on. अभी crude oil तो था मेरे ख्याल से. Let me just check. हो सकता है हो गया. Let me just check, double check. ठीक है, that's cracking is still there. 1 second. I mean, cracking is there. Crude oil. Just a second. ठीक है, cracking is there. अच्छा, मैंने basically cracking का ही background देना था. So let's say, ठीक है, I think it's. I mean, this thing is no longer there. So you don't really have to. I mean, it's no longer there in AS as well. ठीक है, so you don't have to remember this. What I wanted to discuss was cracking. ठीक है. I said, remember, this thing is, even if it's not written in the syllabus, remember, this is still not excluded. I mean, you can't say it's excluded because it's so basic. Some things are just basic, very basic stuff. So, uska thoda bahut the background, I mean, you should know because it's O-level stuff. Okay? If something is in your O-levels by default, you should be knowing that. Okay? Because that will be considered something that's very elementary or very basic. So cracking पे आ जाते हैं. What do you do for cracking? That's you got long chain hydrocarbons. And these you get them from crude oil. They're not very useful. So if they're not very useful, why are they not very useful? Because big molecules have more van der Waals forces. So the bigger the molecule, the more attractive forces they're going to have. So they have more van der Waals, which makes them very viscous. So they've got high melting and boiling points. They're solids or semi-solids. They've got high viscosity, which is why they're not going to mix with stuff as well. So they've got low flammability as well. So they're not most of the time, they're not very useful. So what you do is you break them into smaller chains. So you get a mixture of alkanes, alkenes, and hydrogen gas as well. Okay, so you get three things, or a mixture of three things, or maybe two of those three things, or maybe all three of those things. Okay, so you get a mixture of alkanes, alkenes, and
Sir?
हाँ जी.
So ये thermal cracking या steam cracking है?
Steam cracking नहीं होती, catalytic cracking होती है, plus thermal cracking. ठीक है, catalytic cracking it's Al2O3. Syllabus के अंदर it's catalytic cracking that you should. I mean, you basically use catalytic cracking. You can take it to a very high temperature and it's going to crack. The molecule is going to break into pieces. But that's not done. You add a catalyst ताकि the reaction happens at a lower temperature. So as a smaller are more useful, they're more flammable. And they're also less viscous. And they've got low melting and boiling points. TK. Why? Because they've got lesser van der Waals forces. Come electrons, and so they're going to have lesser. They're going to have lesser van der Waals forces. How do you do that? Cracking is done by adding a catalyst, which is Al2O3 plus temperatures must be around or greater than 450. I said this Al2O3 is obtained from different. I mean, the different rocks have Al2O3 in them. Al2O3 is like a natural component of the Earth's crust. It's mitti uthaoge na, it's going to have Al2O3 in it. Okay, so zeolites are zeolites, pumice. Okay, these are all rocks that have a lot of Al2O3 in them. Okay, this is what pumice. अक्सर लोगों के बाथरूम में पड़ा होता है pumice. it's people use it for skin. Okay, so pumice is something that's got a lot of Al2O3 in it. Okay, plus it's got a very large surface area. It's got a lot of pores in it. Okay, so that's why it's so it's a rock. Chemical nature उसकी पता नहीं लिखी हुई नहीं है यहाँ पे. But anyway, so that's a rock that's got a large surface area, but it's got an Al2O3 in it, SiO2 and Al2O3 in it. So that's used for cracking. Okay, zeolites are also used. That's another rock that's got that kind of the same composition. I say cracking है, you know all of this. उस पे चले जाते हैं now. Alkenes. I said now when we talk about alkenes, now we'll be discussing something that would be very, very, very similar to benzene, and there's going to be a lot of questions where they're going to compare alkenes. So alkenes are very important, especially in A2.
Is this the A2 part?
You can say that because alkenes are kind of very similar. So we're going to discuss alkenes first. That's your AS part, but in A2, you get asked a lot about alkenes, because alkenes are very similar to the compounds that you're going to study. I said, what's an alkene? It's got a double bond. That's what an alkene is. What kind of so this part is important in A2. First thing is about the structure of alkenes. The carbon atom, when it is sp2 hybridized, whenever an atom is making one pi bond or one double bond, that means it's sp2 hybridized. What happens is that carbon has 4 electrons. It's got 4 electrons. It's got a 2s1. It's got a 2px1. It's got a 2py1, and it's got a 2pz1. So it's got a total of 4 electrons. Okay, so that's what carbon looks like. But when this carbon is bonding, and especially when it's making a double bond, what happens is that 4 of the carbon electrons, 3 of them, they are the ones that only bond and they form sigma bonds. So the 3 electrons, they get pulled in 3 different directions like a fan. So 3 of the electrons are getting pulled in 3 different directions. As this one. So as a 3 of the electrons, they get pulled by 3 different atoms. So only 3 of the orbitals, they change shape. 1 electron getting pulled by some atom over here, 1 electron getting pulled by some atom over here, and 1 is getting pulled by some atom on this side. While the 4th electron remains kind of remains unchanged. Nothing happens to it. Okay, so this is what the fourth electron looks like. Okay. So just be careful. I'm going to start with A2 now. I'm going to mix this with A2 as well now. So the 4th electron of carbon, no one is attracting it, and it is in its orbital, right? So this is an sp2 hybridized carbon atom where 3 of the orbitals, they change shape, and you start calling them sp2 hybridized orbitals because they look different now. So you give them a different name. And the 4th one remains unchanged because there's no 4th atom that's attracting that 4th electron. So this is carbon. Now, an alkene is going to be formed when you have 2 of these carbon atoms. Like if you have a double bond, right? So the double bond kind of looks like this. It's if you have an ethene molecule, that's the simplest molecule of ethene. So if I have this molecule, so that's an ethene molecule. What happens is both of the carbons are sp2 hybridized. The first one is sp2 hybridized, and the second one is also sp2 hybridized, which means both of them, the carbon atom is bonded to 3 atoms. So this is how it's going to go down. It's going to be the first carbon atom, and then there's going to be a second carbon atom, which is going to be it's going to be looking the other way around. So that's your second carbon atom. Okay. So you got these 2 carbon atoms, and these 2 carbon atoms are going to link up in the middle. They will form a sigma bond. They will try to attract each other's electrons, and they will start overlapping in the middle. Okay, that's so they will end up forming a sigma bond, and your 2 electrons will be shared right over here in the middle, right in the middle, right? So that's your sigma bond. Okay, let me just change this 1 second. So now एक सेकंड ये मैं शेड कर दूं. अच्छा, so I've got the electron density is overlapping, and that's my sigma bond in the middle. What happens to the blue ones? The blue ones are parallel to each other. Since they are parallel to each other, they will end up forming a pi bond. So that's what will go down with the blue ones. Okay, so एक आपका ये वाला है. ठीक है, there's this one, and then there's this one over here. ठीक है, so the blue orbitals will both overlap from the top and the bottom as well. They will attract each other's electrons, and they will start to overlap above and below. Okay, and that's going to result in the formation of a pi bond. Okay. So the electron density will be maximum in this middle part over here. ठीक है, यहाँ पे भी वही होगा कि the electron density will be maximum.
Sir?
हाँ जी.
सर, तो सिग्मा बॉन्ड के अंदर लाइक इलेक्ट्रॉन डेंसिटी जो एक्सिस पर लाई करती है और इसके अंदर पाई बॉन्ड के अंदर लाइक अबव और बिलो होती है ना.
हाँ. Plus the other thing is there's going to be 2 more sigma bonds that are going to be formed. There's going to be a hydrogen that will overlap. Okay, so there's this other stuff as well. So there's this hydrogen, and that hydrogen will be with its electron will be overlapping with. So this electron will be overlapping with this one. ठीक है, तो यहाँ पे भी overlapping हो रही होगी. ठीक है, these two will overlap, and so on. So there's going to be another hydrogen atom that will be overlapping with this one. ठीक है, these two will overlap, another hydrogen overlapping with this one. So एक और overlapping. ठीक है. which is going to happen over here, and here one more hydrogen. Okay, so that's, now you have to remember the complete structure of this thing. Okay, you'll be asked about every detail about the structure, not the explanation behind it. You just need to know that okay, who's forming the sigma bond in the middle. The orbitals that are forming the sigma bond right in the middle, those are your sp2 overlapping with the other atom's sp2. Okay, it's an sp2 orbital overlapping with the sp2 orbital of the other atom. Okay, these orbitals are sp2 hybridized. That's sp2. This one is sp2 hybridized. This one is sp2 hybridized. And you've got a p orbital which remains unchanged. Okay, remember the three orbitals that change shape. So your beach wala, that's an sp2 overlapping with an sp2. The pi bond is formed when p orbitals overlap. So the pi bond is being formed by जो आपका pi bond है ना यहाँ पे, that is being formed by when a p and p overlaps, right? अच्छा इधर कौन सी overlapping हो रही है? That's if it's hydrogen, then it's an sp2 overlapping with an s orbital coming from hydrogen. ठीक है? So that electron is in s orbital. This electron is in an sp2 hybridized orbital. So they start overlapping and they end up forming a sigma bond. So ये सारा clear है? Is this clear? The example of what an alkene looks like. Is that clear?
Yes.
Achha, now keep this in mind. Right in the middle, okay, now we're going to move towards A2, okay, just a bit. This is what an alkene looks like. Okay? An alkene has a double bond, it's got a sigma, and it's got a pi bond in the middle. The electron density, it's a very electron-rich center. Okay? So the double bond is the place where there's a very high electron density. Who will it attract? Will it attract electrophiles or will it attract nucleophiles?
So nucleons.
The कौन electrons attract of the electrophiles?
हाँ sir, electrophiles हैं.
ठीक है, so it attracts electrophiles very strongly. ठीक है, so focus on the word very strongly. उसको मैं capital में लिख लेता हूँ. ठीक है, very very strongly. Underline भी कर लेते हैं. So alkenes have very, very strong electrophilic reactions because they've got, wherever there's a double bond, there's this pi bond and there's a sigma bond, and there's a very strong electron density, a very high electron density, and that's why the electrophiles, they get attracted to it very, very strongly, and they've got a lot of electrophilic reactions. So now what I'm going to do is I'm going to move towards benzene a little bit. Okay? A benzene looks exactly like an alkene. Okay? So remember, questions are a comparison. Okay? So before discussing alkenes further, now we're going to start comparing alkenes, and we're going to start talking about benzene now. So firstly, remember that this is a different compound. It's a totally different class of compounds. The only thing is that benzenes and alkenes, they look very similar. So what exactly is a benzene? Now, a benzene, the simplified version, and it's known as the Kekule structure. ठीक है. So this one over here is known as the Kekule structure. Or नीचे में बड़ा बड़ा लिख लो, don't use this. But the only reason I'm using this is it's good for understanding. ठीक है, don't use this structure. ठीक है. The simplified version of a benzene is this one, that it's like an alkene. It's a cyclic compound. जिसके अंदर you've got carbon atoms, and the carbon atoms have alternating double bonds. Or ये आपका ना, there's an H there's another H, and there are going to be 6 H's. So there's going to be 6 H's, and so the formula of a benzene is C6 and H6. अच्छा इधर ना एक चीज नोट करना कि if you want to look at the formula and see whether, or if you want to know that is this a benzene or not, 1-to-1 ratio of carbon and hydrogen is only possible in a benzene. So 1-1 ratio, whenever you see 1-1 ratio in carbon and hydrogen, that's a benzene. And anything that's close to 1:1. Normally क्या होता है, it's 1:2. Like alkanes is CnH2n plus 2. It's double. Hydrogens are usually double the number of carbon atoms. Alkenes is CnH2n. ठीक है? Most normal molecules, the carbon hydrogen ratio is 1:2 or greater than that. ठीक है? For an alcohol, it's CnH2n plus 1. So it's even more than double, right? 1-to-1 ratio is only possible in benzene. Now this thing will help you later on when you're doing questions, because the moment you see 1-to-1 ratio, think of benzene. Think of this thing.
So you wrote don't use this. What are we not using?
I mean, I'm just saying don't. I'll explain. Just don't use this structure to represent benzene. Although a lot of people, I mean, that's not the Cambridge specified version. It's like if you even Google benzene, right? This is the structure that's going to come up most of the time. There are going to be multiple structures that are going to come up. For example, if you Google benzene, so you're getting this structure and you're also getting this ringed structure, right? So the ones that you're supposed to use is the ringed structure. Okay? But before that, I'm going to explain why you have a ring over there. Okay? So, I mean, this one is correct as well. Definitely no one is going to cut marks for you if you use this, because it's a commonly accepted this is everywhere. You just go to Google, both structures are used. Cambridge just prefers this one, the one with the ring. Okay? The ring is harder to understand. That's why I told you that the alternating double bond structure, it's kind of easier to understand. Ring pe main aata hu. That's why I'm going to move towards ring. That's why I did not talk about the ring structure. Okay? I'm going to explain what the ring is. I'm going to try and make benzene. Now remember, benzene and alkenes, no difference. Okay? It's the same carbon atom, sp2 hybridized. Okay? So every carbon atom is sp2 hybridized. So all of them, all carbon atoms in benzene. So all carbon atoms in benzene are sp2 hybridized. Benzene क्या ना सी भी carbon और hydrogen का ratio क्या इसमें बन रहा है? It's 1:1, right? I was just saying that अगर एक formula दिया हुआ ना, if they tell you that there is C10H11, the 1:1 ratio ना, that indicates that the formula has something to do with benzene. बाकी molecules में जो ratio होता है ना, that's a lot higher. It's more than double. Hydrogens are usually more than double the number of carbon atoms in most molecules, except for benzene. ये बात काम में आएगी when you do questions related to this. अच्छा, all carbon atoms in benzene are sp2 hybridized. Quickly, ठीक है? What's sp2 hybridized? I did not write the angles over here. इसके angles भी बता देता हूँ. It's trigonal planar and it's 120 degrees. ठीक है? So well, a fan shade basically. So trigonal planar and 120 degrees. Now, benzene is made up of this carbon atom. So let's start drawing the structure of benzene. Okay, we're going to start with 6 carbon atoms, and all of them are sp2 hybridized. That means, okay, I've got this carbon atom, and this carbon atom will be making 3 bonds. So one of them, let's say this direction, and one of them in this direction, like a fan. Okay, so this one is making 3 bonds. Let's move to the next carbon atom. The next carbon atom will be doing exactly the same thing. It will be making 3 of its electrons will be bonded. So it's making 1 bond over here, 1 in this direction, right? Then let's move to the next carbon atom. It's also making 3 bonds. So 1 bond in this direction, 1, I guess, in this direction. Then the next carbon atom, okay, that's also making 3 bonds. And the next carbon atom is also making एक इस side पे, ठीक है, and this last carbon atom is also making 3 bonds. So every carbon atom right now is making इसको सीधा एक second. So every carbon atom right now is making 3 bonds, right? That's sp2 hybridization. Okay? sp2 hybridization is that carbon makes its 4 electrons, 3 of the electrons they bond, and they have an angle of 120 degrees, like a fan. They bond with 3 different things, and the 4th electron is not initially doing anything. Okay? So अब क्या होगा? There's going to be a 4th electron. Each one of them will have a 4th electron. Okay? And that 4th electron initially is not doing. It's not doing anything. So I've got an electron over here, and the next carbon atom next to a carbon atom will also have. It's also going to have a 4th electron, okay, which is initially not bonding. और ये अप्लाई कर दो सारों के ऊपर ही, दोनों को. अच्छा, सारों में पहले एक. So each one has. ये सारे हो गए, and I'll just fix their positions. 1 second. अच्छा, मैं एक्सप्लेन करूंगा रिंग का. अच्छा, यहाँ तक is this clear to everyone?
Yes, sir.
Sana, Siddha, Risha, is this all clear? I say H's and okay, these are all H's. Now basically I'm going to talk about the emergence of the ring. Okay, why do you have a ring? So what did we learn? Okay, I told you that there was going to be alternating double bonds. Okay, the reason why this structure is like incomplete or kind of not correct is when you have 2 p orbitals together, what will they do? They will end up forming a pi bond, right? So what's going to happen is you'll have a couple of 3 pi bonds formed. These 2 will start to overlap with each other, and what they'll do is they'll form a pi bond, right? Achha, these 2 are parallel to each other, right? And they will start overlapping with each other, and they will also form a pi bond. So there's going to be another pi bond that's going to be formed over here. And ये दो भी कर लेंगे pi bond, ठीक है? They'll form a pi bond with each other. They'll try to attract each other's electrons, and they will eventually merge with each other, and they will overlap, right? So that's the origin of your 3 double bonds. alternating double bonds. But the question now is, ठीक है, the main question is, okay, if these are forming pi bonds like this, ठीक है, why don't, अगर इसको expand करें, so if you focus on this one, or just go let me, so if you focus on this electron, if this electron is overlapping with the carbon that's on the left side, it can also overlap with the carbon that's on the right side. It can do that as well. So why don't these two overlap? ये दोनों भी तो overlap कर सकते थे. Let me draw it with a different color. So these two can also overlap with each other, right? As similarly, if this orbital is overlapping with this one, this can also overlap with the one that's on the top as well. So these two can overlap with each other, right? And why don't they start overlapping with each other? So the end result is that you don't actually get 3 pi bonds. What you get is you get a system of pi bonds where all of them, they kind of get mixed up. ठीक है, ये इधर overlap कर रहे हैं, this is overlapping with this one. So that's where the ring comes in. You don't actually have 3 double bonds, or you don't have localized double bonds. What you have is a delocalized structure. Okay, this electron over here can overlap with this one. It can also overlap with the one that's on the right side. So the electron kind of gets delocalized. So आपका जो proper structure है ना, that's this one. It's going to look like this. Like if I draw this now, if I draw this one now, what I'm going to do is I'm not going to draw double bonds in the middle. What I'll instead do is I'll put a ring in the middle. Okay, that ring indicates that I don't exactly know where the double bond is. Okay, the double bonds have all gotten mixed up, and you've got a ring of delocalized pi electron cloud. Okay, that's what this ring is. It's a ring of delocalized pi electron cloud, or pi electrons. So clear? Is this clear what benzene looks like?
Yes, sir.
Okay, Saru, clear. Okay, that's what benzene would look like. Now, one very important thing, it was last point at TK, which is because this is where I'm going to compare it with alkenes. TK, that's the major difference between an alkene and a benzene. ये दोनों आपके सामने है. Which one do you think? That's an alkene. An alkene is formed with 1 pi, one pi bond. A benzene has a lot of pi bonds, which have gotten mixed up. Which one has a higher electron density? Alkene के पास high electron density है या benzene के पास?
Benzene.
It's, remember we're talking about when I talk about electron density, I don't talk about the number of electrons. I talk about how dense the electrons are, ठीक है? Or how concentrated the electrons are. So in alkene, the electrons are more concentrated. They're more localized. वो एक ही जगह पे ना, the electrons are overlapping. The electrons are right over here. So the electron density is higher in alkenes. It's actually lower in benzene. Why is it lower? क्योंकि वो जो electron density है ना, that's, although there are more electrons, but the electron density is kind of distributed. ठीक है? This is what happens. कि एक second. Okay, this electron, not only is it getting, is it overlapping on the right side, at the same time, the same electron is also overlapping with the orbital on the left side. So uske jo electrons are, they're way more distributed compared to the previous one. Is that clear?
Yes, sir.
Sir?
हाँ जी.
सर तो इसके अंदर मेन रीजन ये है कि एल्कीन जो है वो फिक्स्ड होता है ना, मतलब एक ही जगह पे पाई बॉन्ड बनाते हैं, वेराज बेंजीन जो है वो हर जगह पे बना सकते हैं, इसलिए वो ज्यादा.
हाँ, तो वो उसका मसला ये होगा कि इलेक्ट्रॉन आधा वो उधर शेयर कर रहा है, तो आधा वो उस साइड पे शेयर कर रहा है. तो एंड रिजल्ट ये होगा कि इलेक्ट्रॉन डेंसिटी कम हो जाएगी, ठीक है। ऑल्दो ओवरऑल टोटल नंबर ऑफ इलेक्ट्रॉन ज्यादा है, देयर इज अ बिगर इलेक्ट्रॉन क्लाउड, लेकिन द डेंसिटी इज लेसर, ठीक है। सो
सर
हाँ,
सर वो 24DNPH के अंदर भी इस तरह से सर्कल है, वो भी इसी वजह से होता है ना?
वो कहाँ से आ गया, उसको छोड़ दो। वो 24DNPH में सॉरी बेंजीन था, हाँ वो तुम्हारी बात समझ आ गई है, उसमें भी बेंजीन था, लेकिन वो उसको छोड़ दो, उसको साइड पे करो अभी। अच्छा वो था कि इसका बस आखिरी पॉइंट लिख लेते हैं कि इलेक्ट्रॉन डेंसिटी इन अ बेंजीन pi electron cloud is significantly lower compared to an alkene pi electron cloud. अच्छा it's significantly lower when compared to an alkene pi electron cloud. ठीक है, उसकी electron density is a lot higher, ठीक है. This is way more distributed, and you can also guess it from the bond strength. Like you've got double bonds. अच्छा you've got कौन सा होता है, so you've got single bonds, you've got double bonds. And alkene is kind of in the middle. उसका जो bond होता है ना, that's like one bond and one dotted, ठीक है. That means the double bond is not complete. It's like double bond यहाँ पे बना था, लेकिन it started sharing electrons with the other one as well. So the double bond is not. It's kind of like incomplete, ठीक है. So this is what an alkane looks like. This is what an alkene double bond looks like, and the benzene one is kind of in the middle, ठीक है. तो bond strength भी ना उसकी weak होगी. So I'll just quote very last चीज बस कर लेते हैं कि किधर data booklet. I'll just show you the values of benzene, ठीक है. तो remember benzene का जो bond है ना, that's weaker than over here, यहाँ पे. So you can see carbon single bond carbon, that's 350, carbon double bond carbon, that's 310. और benzene जो है ना, that's like in between a single bond and a double bond, so that's 520. तो double bond से it's weaker. Double bond is what, 610. मैं वो values भी लिख लूं. And the single bond is 350 kilojoules per mole. तो ये मैंने आखिरी चीज यहाँ पे लिख दी है, ठीक है. लेकिन अब बस the takeaway from this class is, ठीक है, we're going to talk about benzene and we're going to compare it with alkenes. So kind of looks like an alkene, but it's not an alkene. इसकी जो electron density है is significantly lower. Plus you've got this electron cloud that's on top of it, ठीक है. और इसकी अभी इसी में खत्म कर लेते हैं. शेप वगैरह क्या होगी? It's a completely planar molecule. Remember वो the shape for an sp2 hybridized, it's trigonal planar. So this is hexagonal planar, क्योंकि if you shape fans को अगर connect करोगे ना, that's going to form a hexagon. And all the angles, so it's a completely planar molecule. It's not a three-dimensional molecule, it's completely flat. And the angles are 120 degrees. वही alkene वाले angle है, everything is the same. All of them are sp2 hybridized. और इसमें मैं थोड़ा सा डिटेल ऐड कर दूं कि ये sigma bonds कौन बना रहा है? The sigma bonds are made from let me add the details over here. I mean, they ask for the details sometimes. They give you a 5-mark question. So the carbon bonds are formed, the sigma bonds. उनके बीच में जो sigma bond है, that's sp2 overlapping within sp2. Carbon and hydrogen bonds in this are formed when they're also sigma bonds. That's an sp2 overlapping with an s. और फिर इसमें ना pi bonds कौन बना रहा है? That's p and p overlapping. I mean, it's the same as a normal alkene, ठीक है. तो ये सारा क्लियर है? कोई क्वेश्चन नहीं है इसके बारे में? सिद्रा, सना, हसीब, उमर, क्लियर है?
Yes, sir.
Yes, sir.
तो बस ये याद रखना दिमाग में कि एल्कीन में इलेक्ट्रॉन डेंसिटीज हाई है, बेंजीन नॉट दैट हाई, ठीक है? चलिए ठीक है, लेट्स कंटिन्यू नेक्स्ट टाइम, ठीक है? ओके एवरीवन, टेक केयर, हाफिज।